Mr. Cowan here to help you with the second to last, I don't know, actually it's not in the textbook, come to think of it. Our section today is called percent of error. If you need to, first pause whatever this assignment number is, percentage of change word problems. Take a look at your answers, come on back for the second page when you're ready. And the second page, pause and return when you're ready to move on. All right, folks, goal for today is another relationship, finding a percent of error. Now think about all the stuff we've been to. We know that percent is a relationship comparing a number to 100. We know that often we compare a part to a whole. Sometimes we look at the increase or decrease, in other words, the change, compared to the original number. Today, we're going to look at the percentage of error. And I'm going to leave you with the question mark, what would go down below? Of course, when we can set up a proportion, we can solve for a missing piece. All right, so first things first, I do have some notes. If you are in class with me, you'll be getting a piece of paper. If you're at home, you can download the page, open it up, and start with the definition. A percentage of error is a measure of how inaccurate an approximate value is. That would be, of course, a guess, compared to the exact value. So I'm going to write this in a couple ways. Obviously, percent compares to 100. You might choose not to write approximate minus exact over exact. Maybe you write what I just started with, the error over the exact. Maybe you write how much you're off over the exact, but that's what we want to know. How much were we off compared to the exact amount, and what is that percentage? Now, as an example, I'll get into Oprah Winfrey. If I were to set up to find a percent of error, I know that my number, the missing piece, is going to be compared to 100. Now, I went ahead and I estimated that Oprah's age was 65. I know she's getting up there. I don't know how old she is. But when I looked it up, as of this year, right now in March of 2023, she was 69 years old. So the first thing I do is I write in that exact number. Maybe I'll still use green. 69. I don't know why. I gravitate toward the denominator first. Now, as for my error, what I'm going to do is I'm going to take my approximate, my estimate, my guess. I'm going to subtract the actual. And folks, I know that's a negative, so here's what I'm going to say. Just come up with the absolute value. In other words, I'm 4 off. That's the number that should go up there. I'm going to compare my the amount that I was off, 4 years, to the actual age and find out what that percentage is. Now, of course, I'm going to multiply some number times p, and then 100 times 4. I don't know what 69 times p is, but I know 4 times 100 is 400. And of course, if I divide this out, I could have come up with a guess. My apologies. 4 compared to 70, I don't know. It's probably 6%, 7%, something like that. I believe you can trust. Actually, let me go ahead and tell you the exact, and then I'll approximate it to the nearest tenth of a percent. So if I were to divide 400 by 69, I think you guys can trust my division here. What I in turn calculated was 5.797, and it sure looks like it goes on. It does not repeat, like the next digit is a 1. So if I were to round to the nearest tenths place, is that closer to 7 tenths or 8 tenths? It is closer to 8 tenths. So I had about a 5 8/10% error. It's not bad. I'd rather have 1% error. It means I'm much closer, but I was only about 6 percentage points off. I'm going to do another example. I want you to ask yourself how these examples are similar, how the examples are different. For Mickey Mouse, I know he's getting up there, so I actually guessed 100. Now, I'm going to be honest, I had trouble finding the exact answer to this because some people measured it according to the first movie he was in. Other people, when was he first drawn? I believe the first movie he was in was November of 1928. So as of this year, not quite 95 years old, 94 years old. I'm going to go ahead and set up a percentage over 100. The exact age, I always go to that. And don't forget, take the absolute value of the difference of my guess and the exact age. Now that doesn't mean take the opposite of 6, right? Absolute value means how many steps away from 0. Therefore, it's always positive. So it's going to be 6. I'm going to compare 6 to 94. That's pretty close to 100. I don't know. 7%, 8%? Let's find out. So we go into the cross products here. 94 times P and 100 times 6. I don't want to know what 94 P's is. I want to know 94 P's are. I want to know what a single P is. So let's go ahead and divide both sides by 94. And provided you can trust my division, I'm just going to go ahead and divide this out with my own resources. 3, 8, dot, dot, dot. If we round it to the nearest tenths, would that be 6 and 3/10, 6 and 4/10? That's about 6 and 4/10% of error, which was pretty close to my last guess. How about that? So let's do another one. I want you to look at how these problems are similar, how these problems are different. Obviously, this is an old notes. I did not use the current sitting president. I used President Obama. Sorry about that. I could have updated the notes, but I didn't get a chance to do that this year. I'm going to go ahead and guess that he is 58. Now, I looked up his age, and as of right now, he's 61. That seems pretty close, doesn't it? Question is asking percent, so I compare that to 100. The exact age, remember, we're always talking how much you're off compared to the exact. So that's the easiest number for me to figure out, that 61 is the exact age. Let's go ahead and subtract to find the absolute value of negative. Well, I'm 3 off. I could have known that without showing that. Many of you will not show that, and that's a-okay. 3 compared to 61 is almost 3 compared to 61 to 20. That's 5%. So I'm getting pretty close. I would have thought it would have been smaller because I was only 3 off. But if I compare 3 to a smaller number down here, then the percentage won't be so small. 61 times P, 3 times 100, divided by 61. And if I were to divide 300 by 61, 4.918 dot, dot, dot. But I want to go to the nearest tenths of a percent. So 4 and 9/10 or 5 and 0/10. That'll be 4 and 9/10. And I had a student ask earlier, Mr. Callan, do we need, if it goes to 0.0, would we need that 0.0? Yes, because if you would not write that 0/10, it looks like you've rounded to the nearest whole. So if they ask you to round to the nearest tenth of a percent, even if it's 0, you need to put that digit in. For us, it was 4 and 9/10%. All right, look at how those problems are similar. Look at how they're different. One I ended up being too low. One I ended up being too high. But it doesn't matter, because once you take the absolute value, you don't worry about the positive or the negative. You just compare how much are you off, how much are you away, to the exact amount. Let's do one more, and then I'm going to cross off Robert Pattinson. This is old notes, like I just mentioned. Some of you don't even know who that is, and that's okay. Jennifer Lopez. Let's just take a round guess of 42. I don't know. Well, I looked up her name, looked up her age. She's 53 years old. So I was quite a bit off. If I want to find a percent versus 100, and her exact age is 53, and I end up being 42 minus 53, holy cow, the absolute value of negative 11, I was 11 years off. Now, you might say, no big deal, Mr. Callan, it's only 11, but take a look at it compared to what, well, think about previous problems. 53 times P, 11 times 100. will be 1100. Divide that out to find the percent. Ooh, not a very good guess. So in fact, I was approximately 20 and 7/10%. And some of you might be saying, well, why? 11's not that far away. Well, sure, but 11 compared to the exact of 53. Because the 53 is smaller, that 11 is just a bigger chunk of 53. So that was not a good guess at all. All right, as I mentioned, example 5, we're going to depart from the percent error and just review some previous type of questions. Now, in this case, we assigned 20 assignments last quarter. Next quarter, increase by 10%. This is only a hypothetical. How many assignments will there be in that next quarter? Now, I want you to think about this. We know that there were 20 assignments last quarter. We know it's going to go up. We just don't know how much. Oh, but we do know that is 10%. So with that as the case, could I find how much it changes? All right, there we go. Percent of change is something we've done before. 10%, 10 compared to 100. 20 assignments is the original. I don't know how much it increases. Although you can either choose to write multiply by 1/5 or divide by 5 parts and quickly find that the increase is 2 homework assignments. However, be careful because that's not what the question is asking. The question is not asking how many will it increase. The question is asking how many will there be. Naturally, 20 plus 2, 22 homework assignments. So this is kind of a two-part problem. Part number 1, find out how much it increases. Part number 2, find out where it gets to. Now, before I go on to one final example, just look at those problems are similar, look at how they're different. Problem number 4, example 4, is a percent of error problem. So we compare how much we are off, our error, versus the exact amount. Whereas problem number 5 is a percent of change problem. We compare how much it increases or decreases, which actually we did not know, versus the original amount. Problem number 4, we have a missing percentage. Problem number 5, we know the percentage, we have a missing part, an increase, a change. All right, one final example. Pause if you want to read it on your own. Come on back when you're ready. So what are we talking here? 50 cents per pencil. Run up the price, 150%. What was the cost of a pencil? After the increase, of course. So here we go again. I don't know about you, but I see a percent. I see 150%. And what is it we know? We know that it starts 50 cents, goes up. We don't know how much. We do know that's, well, this is very similar to the last problem. Can we find how much it actually increases? And of course, the answer is yes. So let's start with 50 cents. Let me go ahead and write it in dollar form. 50 cents right there. I guess that means we don't know the change. We don't know the increase. Many folks will decide to reduce this fraction to 3 over 2. I think that's a wise idea because now our cross products are much easier. 2 times C is equal to 3 sets of 50 cents. That's $1.50. Split it up so that you can find out that a single increase, a change, I could have used I for increase, would be 75 cents. And before you stop the problem, ask yourself, is that what the question's asking? No, it doesn't want to know how much you're going up. It wants to know what the price was. So we're going to have to go ahead and add 50 cents with 75 cents to get some very expensive pencils of $1.25. Now, I put a little visual here. Imagine if that pencil just were increased by 100%. I thought I had that cloned. Hold on. So 50 cents is $1, and it has to be more than $1, right? Now I actually included that red below so you could see. So this is half of it, so there's another, that is a 50% increase. There's another 50%, that's a 100% increase, double the size. And then 150% increase is more than double the size. So it can't just be 50 cents and another 50 cents. All right, that's what I got, folks. We do have an assignment, whatever that assignment number is, whether you're in the classroom with a piece of paper or at home working on Kami. Take care, do well, let's grow.